Hey guys, welcome back to Rocket Gyan. Hey guys, welcome back to Rocket Gyan. So today we'll be witnessing one more exciting launch of, you can say, this week. So today was a very busy day for me and for the space industry too, as today there were three launches scheduled, and fortunately or unfortunately I don't know, but the first launch, which was the Japanese rocket Momo 5 launch, which was to be streamed earlier, um, was rescheduled for tomorrow. But the Starlink launch and the Rocket Lab launch is there, so we hope that everything goes correctly. So today we'll be witnessing the Rocket Lab launch. So what is Rocket Lab, what it is doing and all, we'll be seeing just in a minute guys. And yeah, here we are. So let me just tell you a little bit about the Rocket Lab as a company. Many of you must not be knowing about it. So Rocket Lab is basically a small sat launcher, and small sat launcher means it does not have a very high payload capacity to the low Earth orbit. It's just a small sat, CubeSats. It launches CubeSats. CubeSats are what? CubeSats are basically, you can say, a shoe box sized satellites. Yeah, satellites are no longer that big enormous sized satellites. They are no longer like that. They have shrunken in size because of the advancement in technology, and that's why. So it offers two launches: dedicated one or ride share will be happening today, and dedicated, it happens when there is a, you can say, not a cube set, but yeah, some lighter satellite. So then dedicated one can be uh, taken, but dedicated is a more costly one than a ride share. And ride share is happening today, where three payloads. I'll discuss about it later on. So let me just, so it has, yeah, vertical integration, which is very essential in a rocket company, because vertical integration basically has maintains the integrity during the launch when the vehicle is vertically integrated. That's the reason. And yeah, that's about the company. So let me just now tell you about the mission profile. So here we are at Don't Stop Me Now. So Don't Stop Me Now is basically, see, mission name is Don't Stop Me Now. Rocket, we are using Electron rocket, and this mission was scrubbed previously and is happening today. Previously it was scrubbed on, you can say, on 11th, I guess. Yeah, 11th. So yeah, the mission or overview is like that. It will be launching three satellites, not the three organization satellite, not the three satellites. Satellites are much more than that. One will be the ANDESITE, which is a NASA endeavor, NASA's CubeSat launch initiative. Other will be the this one will this yeah the other will be the NRO, three payloads built by the NRO, National Reconnaissance Office. And the last one will be the M2 Pathfinder satellite built by the University of New South Wales. These are the three satellites, three organizations satellites, which it will be launching on. And yeah, pretty much it. So let me just go now to the rocket itself and give you a quick overview of that. Just here we have the Electron rocket. Here's the Electron rocket. Frequent and reliable access to space for small satellites. Yes, small satellites are will basically revolutionize space, access to space basically, and that access to space is being revolutionized by rocket. Like, you can say that, because no other small sat launcher is there till date, and Rocket Lab is getting a ton of customers. That's the reason. So you can say, why is it small sat? It has only 225 kg of payload capacity, and that's the maximum payload. And the nominal payload which it takes is 150 kg, and it has two stages, and height is 17 meters. Falcon 9 height is 75 meters, so it comes nowhere to that. But yeah, it also has ambitious plan of recovery of first stage through parachutes and catching it with the helicopter. So you can't deny the fact that it is also pushing to the limits. So, and this is the plug-in payload, means nothing but just a fancy name to for the fairings, you can say. The kick stage. Kick stage will be used today. Kick stage, you can see these what can these pockets or the shelf, I can say. Here will be the satellites will be placed here only, and will be pushed outside by the kick stage. Kick stage is basically used when in a ride share mission, when when other satellites required a different orbit. So kick stage can raise or deorbit, not raise or decrease the orbit, so as to meet the person's requirement. And finally, when the kick stage work is done, it performs a deorbit maneuver and it burns up in the atmosphere. And there is the second stage. Second stage is powered by one Rutherford engine, which is a vacuum optimized engine, in which the nozzle of the Rutherford engine is extended so as to meet the vacuum requirements. It has a 333 seconds of ISP. ISP is basically the mileage. Carbon composite material makes it lighter and more rigid, so it is used in that. And these are the cryogenic valves, helium pressurization valves. No need to be worried about it. These are avionics, basically these are the flight computers. And what we need to be worried about is the new propulsion cycle. Not worried about, this is also a reliable engine. It's a Rutherford engine in which 9 Rutherford engine will be used, and it is the fuel will be the RP1 and the oxidizer, and the turbo pump in it is not run by the fuel itself, but the turbo pump is run by the batteries. Okay, that's the main thing of the Electron rocket, that this is the first rocket in which the batteries are used for learning the Electron rocket. Hi, if I will be pronouncing your name wrong. Lelbar. I can't just Lelbara. Uh, Sorry if I have pronounced your name differently. But yeah. Oh, and I just found out that you weren't able to see see what was happening. So yeah, I was telling about the kick stage, and these are the pockets which I was telling about. These are the pockets in which the will be no the satellites will be placed and will be pushed about. This is the second stage. This is the carbon composite. These are the avionics, which is a flight computer. This is the new propulsion cycle, in which the RP1 is the, you can say, the liquid fuel, and the oxidizer is the oxygen, and it has a turbo pump which is powered by batteries. This is the first stage. 192 kilonewton of peak thrust and 303 second of ISP. Yeah, and the most exciting part of it is that all components of Rocket Lab Electron rocket is 3D printed. That's so good, right? So we have talked about the Electron rocket. Now we should look about the kick stage itself once. So kick stage, here we have the kick stage, and yes, here. So kick stage, there is nothing but one Curie engine is there in kick stage, which is be named after Marie Curie. You can say that. I should play this video once, and it should clarify all your doubts. So we can have this video played once. Have a look at it.
The kick stage is a unique final stage of the launch vehicle and provides Electron the capability to precisely inject customer payloads into their final designated orbit. Stage 2 takes the kick stage to an elliptical parking orbit. Then the kick stage separates. We leave the second stage in an elliptical orbit with a low perigee, or the lowest point in the orbit. At each perigee, it dips lower and lower into the Earth's atmosphere, finally burning up on re-entry. After a coast phase, the kick stage's Curie engine ignites and circularizes the orbit. Once the kick stage has deployed all payloads, the Curie engine has the ability to reignite and perform a deorbit maneuver, enabling it to re-enter the Earth's atmosphere and burn up, leaving nothing in orbit but the satellite payloads.
What it should be, right? That's a good thing. And here we have the satellites. You can see these are the shells or the pocket where the satellites are placed and pushed apart by the kick stage. This is required when we need to have different orbits for different satellites, so it is required by that. It is so good, right? Now once it deploys all the satellites, then it will just re-enter the atmosphere, deorbit, perform a deorbit maneuver and re-enter the atmosphere. And hopefully we'll see the launch today, because last time it was scrubbed due to weather violation and I don't want to happen it once again. So that was it about it. Let me just see if we have the stream for it. No, we have not got the stream till now. We'll start at 10:10 a.m. Okay, no problem. So that was pretty much about it, guys. Yeah, the pre-launch preview. We need to see the pre-launch preview too once. And here we have the pre-launch preview. So guys, liftoff time, it is subject to change, but here we have the largest longest launch window, you can say, of 2 hours, 2 hours ish, you can say. But yeah, that's the thing. So the mission name is Don't Stop Me Now, and it is named Don't Stop Me Now after, you can say, as a respect to one of the member who recently died of the company, and that's why they have named this mission as Don't Stop Me Now. And three undisclosed pillars of NROs and NASA, that's okay. The customer says okay, okay, okay. Pad A launch complex. So it does not launch from US, it launches from New Zealand. It is a US based company, but it does not have its base at launch pad at USA, but at the New Zealand. So you can say that this company is located in both countries. So yeah, that's one thing. And lower, so here we have the M2 NRO's payload mass is undisclosed, and M2 Pathfinder mass, which is 4 kg, and ANDESITE is 3 kg, and that too is 0.38 into 8, means 8 satellites are there which are of 0.38 kg, 380 gram. That's the power of CubeSat, guys. It is so light, and you can actually see how it is used, right? So no first stage won't be land. The booster will splash down uh, destructively. Basically, Electron was the Rocket Lab was testing its equipments, its sensors, and its technology in recovery and the re-entry. And but it is not doing in this launch. It was testing its technology from for past, you can say, 5 to 6 launches, but not today. I don't know why, but not today. So fairing will not be reused. This is first flight of Electron, and yeah, here we have the NASA mission profile. You can see that. So Electron, okay, that's good. These are the payloads. That's national reconnaissance, ANDESITE, and Manto 500. Okay, cool. Okay, cool. No problem. So now we are just waiting for the stream to start, and once it starts I'll just revert back and you can see that. So guys, anything else you want to ask or you want to say, I'm here, I'll answer all of that. Anything, or else I can explain you this diagram itself, what this diagram is. As you can see, if I explain you this diagram, this is basically the electron rockets diagram. Okay, and here we have the oxidizer pump and the fuel pump. These are the turbo pumps. Turbo pumps, why is turbo pumps required in an engine? Turbo pumps are required so as to you can say accelerate the pumping of fuel to the engine. Okay, that's the thing, because it typical rocket engine, it actually burns tons of rocket fuel per second. That's why the rocket fuel needs to go to the engine very fastly, and that's where the turbo pumps comes in, which accelerates the fuels to reach the combustion chamber. Here's the combustion chamber where actually the engine produces thrust. Okay, so this turbo pump is where this is the new design, where the turbo pump is powered by the electric motor. This is the electric motor which is used to rotate these two turbo pumps. In other engines, wherever the turbo pump is, there they don't use the uh, electric motor, but what they use is they use the fuel lines itself to rotate the turbo pump. There, yeah, that's something of typical design, but because they are using the fuel lines to rotate the turbo pump itself, then it causes the wastage of fuel. Okay, that's one major disadvantage of that. Yeah, we can have closed cycle to remove that issue, but mm, I like this modern approach. This is a modern approach, but here also we need to ditch the batteries, which is of great mass. That's why Electron ditches the battery once in you can say once that batteries are discharged. That's the thing. And there, here's the heat exchanger. Heat exchanger is used to, what you can say, cool, used to keep cool the nozzle of this engine. Okay, and yeah, the engine is not this nozzle. Everyone says that it is such a huge engine just by seeing the nozzle. Nozzle is nothing. Nozzle is the least important part. Whatever the engine is, above that, that is the most important part. Okay, that's one thing. And yeah, and there is one first stage recovery they have seen. I have made one video about it in my channel too, where the first stage recovery, you can say I have actually shown how Rocket Lab is pursuing their first stage recovery, and why SpaceX is not doing that. SpaceX is using propulsive landing. Why is it so? It is using parachutes. Rocket Lab is using parachute, and SpaceX is using uh, propulsive landing. They both have different you can say philosophies. That's why it is happening. And if I let me just see you let you see this, what I'm talking about, how it will uh, land the land not land but catch the first stage. So if I go to that, and if I have the stream, I can show you how it is planning for mid-air recovery. So here we have okay, wait a sec guys, it's just yeah, okay. And now let me just switch it so that you can also see that. catch basically through helicopters. That's the thing. How it will do it in this video it is explained. So this has the dummy first stage. This helicopter has a dummy first stage which it will drop, and the second helicopter has the hook from which it will catch. This technique is known as mid-air recovery. As you will see now, the second helicopter will go close to it and try to catch it. Now the parachutes will deploy. The small parachute which you are seeing hanging down from that is basically a balloon. That is only helpful in catching the rocket, the first stage. Where once it catches, then the parachute just closes up. And it will, once it catches, then the helicopter will take it to the desired location. This is such a good technique because there is no splashdown involved, so that's why we are removing the corrosive nature of salty water to ruin the engines. So it's a good thing. Now I think they must have started this team. They haven't. 10, 10 in less than 10 minutes there will be the launch, and I think so they are having the launch so late. That's why this is happening, if I'm not wrong. No worries, just have it once. Okay, so here was the launch of that, and I just made you see what will happen in actual recovery, and you just saw that thing. So yeah, that was that. So we are just waiting for it to happen. uh Guys, do you have any question or so I can answer? And if you haven't subscribed till now, just subscribe because many more launches are coming up. um, mm, Before the many more launches, the next launches of the SpaceX, and it is uh, scheduled from about 3-5 hours from now. You can find it on my channel. I'll be live for that too. SpaceX Starlink mission, and that Starlink mission is not only Starlink mission. That is basically the first rideshare mission also of SpaceX, in which they will be having 58 Starlink satellites and 3 SkySat satellites, which is the Earth imaging satellites. So yeah, that's the first uh, you can say the rideshare program of SpaceX. That's the good thing, right? Now we can till the till Rocket Lab comes live, what we can do. Okay, give you a little bit info about. Yes, we can surely see these Rocket Lab's other vehicles. We can surely see that. So photon is not a vehicle, but it is a, you can say it is a vehicle, but not a rocket. Photon is basically you can say, what do you mean by that, a transportation vehicle to the moon and beyond. Okay. uh, it once in payload, it like kick stage, right? Like kick stage also has its has other satellites into it, and it just pushes it away into the desired orbit. Same is with the photon, but the photon is basically made for the interplanetary and for the moon, so that's why it is there. Okay, connection timed out, cool. Wait a sec. Why the connection gets timed out all every time during the launch? I just don't understand. Just okay. No problem. If I am unable to show you, no problem. I can just uh, make you see that, make you listen about it. So photon is, yeah, what I saw, what I said it was right. Photon will basically taking all the satellites to the lunar or the Earth orbit. Okay, sorry, the interplanetary orbit, so that the CubeSats can also go to there. Otherwise the other till now what we did, only the big satellites of the government agencies were able to study the moon or the interplanetary area, but now that's not the case. The rocket lab is revolutionizing that, and it is giving access to the small sat makers, you can say, so to explore the space around them, and that is so good, right? And we are just having issues with the Rocket Labs website. Okay, no problem. So yeah, that's the one, that's thing. And the other one, if you can see, is no, I don't think so. Yeah, the rocket lab has only one rocket in its lineup right now, and that is Electron, which is capable of putting, the 225 kg payload. And um, yeah, pretty much it. We're just waiting for it to come alive now. I don't know what to talk about now. If you have any question, guys, you can ask me. Then I'll once it comes live, then so I'll be there explaining each and every step what they will take. But before that, if you have any questions, you can ask me right now. You can just read this. This is also good information to be read about, and listen. You can say to listen, not listen, but uh, know about the rocket engine. Rocket engine itself are very good to learn about. That's the thing. Just waiting for it to come. You can just read it. I'll just pause it here. You can just read this. Once it comes live, we'll just switch over to it, and I'll be there with you. No worries. Just waiting for it to come live. I can't. No, I don't know why it happened like that, because the Launch was scheduled to happen now, and it has not been done till now. Don't know what is happening. Okay, 19 minutes to the launch. It will typically start at t minus 15 minutes. Okay, 4 minutes we will are there, and for the, you can say, the coverage to begin. Once it is there, then we'll be able to see it.
welcome to the live broadcast of Rocket Lab's 12th Electron mission, Don't Stop Me Now. I'm Max Muncy, and I'm coming to you live from Rocket Lab Mission Control. Thanks for joining us as we get ready to go to space once again. Earlier in the week, we stood down from a launch attempt for this mission due to high ground winds at Launch Complex 1. When it comes to launch, there are thousands of things within our control, but the weather simply is not one of them. We're back on the pad today, but we're still keeping an eye on weather conditions and are currently green for launch at T0. Earlier this week, it was high ground winds that caused us to stand down, and today we're tracking heavy cloud this time. At this stage, it's likely we could go into a planned hold at T-minus 12 minutes to wait for a gap in the weather for launch. Today's mission is a rideshare launch to low Earth orbit for NASA, the National Reconnaissance Office, and the University of New South Wales, Canberra Space. One of the satellites on board today is the NASA ANDESITE satellite. This payload has been created by students and professors at Boston University to study the Earth's magnetic field as part of NASA's Cubesat launch initiative. There are also 3 payloads on board which are designed, built, and operated by the NRO. This mission was procured under the agency's rapid acquisition of a small rocket or RAISER contract vehicle, which allows the NRO to explore new launch opportunities that provide a streamlined, commercial approach for getting small satellites into space. This mission follows Rocket Lab's first dedicated mission for the NRO, which was Birds of a Feather, and that was launched in January this year. The final small sat onboard Electron is the M2 Pathfinder satellite, a collaboration between the University of New South Wales Canberra Space and the Australian government to test communications architecture and other technologies. We'd like to thank our mission partners for choosing Electron as their ride to space today. It's great to be able to meet the needs of a diverse payload class, from national security to research projects, all on the same mission. Now, as usual, we'll be ending the live broadcast shortly after kickstage separation, so we won't be bringing you live video of payload deployment. Keep an eye on our social media pages for updates regarding deployment after the webcast has concluded.
So guys, here we are with the Rocket Labs launch, and you can see the Electron sitting on the pad, Electron rocket sitting on the pad, and if I'm not wrong, being topped up by the fuel again and again by Electron, by the Rocket Lab company, or what else will do. So so today, as he explained it, so
today's launch is taking place from Rocket Lab Launch Complex 1 on New Zealand's Mahia Peninsula, the world's only private orbital launch facility. From our inception, the mission has been to open access to space for small satellites, and key to that access is launch frequency. We designed and built a launch site that can support up to 120 missions per year to offer our customers unprecedented access to space. Today, Electron is standing tall on LC-1 Pad A, but just out of the frame, work is continuing on Pad B, an additional launch pad within the same complex. By operating 2 pads at the same site, we eliminate the time required between launches for a full pad recycle, and instead we can launch back-to-back within hours, not days, weeks, or months. We've made something of a habit of building launch sites here at Rocket Lab, and the pads at Launch Complex 1 only comprise 2 of the 3 pads that we operate. Right now, we're preparing for our first mission from another pad, Rocket Lab Launch Complex 2. This pad is located at the Mid-Atlantic Regional Spaceport within the NASA Wallops Flight Facility in Virginia, USA. We are just weeks away from our first launch from this site, a dedicated mission in partnership with the Department of Defense's Space Test Program and the Space and Missile Systems Center's Small Launch and Targets Division. Our team recently conducted the vehicle rollout and integrated systems tests to verify launch systems on Electron and the ground systems ahead of this exciting first mission. Let's check out some of the action going down at Launch Complex 2.
You're such a good thing, right? Yeah, 3D printed, everything is 3D printed. Guys, if you haven't subscribed till now, just subscribe, because here you will find exciting launches of various space agencies only on this one channel. You don't have to subscribe every other channel. Just subscribe this channel and you will get every other launch. This is how it basically gets to the launch pad. static fire करना.
Stay tuned for updates about our first mission from LC2 in the coming weeks. But for now, let's head back to LC1 as we hit T-minus 7 minutes and 30 seconds until launch for today's Don't Stop Me Now mission.
Confirm AFTS is green and enabled for flight.
FTS is green and enabled.
Is green and enabled for flight.
FTS is green and enabled for flight.
Top clamp is open.
We are basically, if I'm not wrong, doing the polling. Everything is good or not. Mission control audio.
Proceed with strong back retract for flight.
Yeah, the mission control audio
Tracking
is also
strong back.
setting to listen. Okay, listen to that. Okay, so everything is looking good today. Only the problem is with
You're
the
looking at our 12th Electron launch vehicle on the pad here at Launch Complex 1. The Electron rocket is a 3-stage liquid-fueled launch vehicle designed specifically for small satellite missions. Today, Electron has flown 48 commercial and government small satellites to space. Successful deployment of today's payload will bring that total count to 53. The satellites on board this rideshare mission are safely encapsulated inside the rocket's nose cone structure, which you can see on the top of the vehicle, and that's otherwise called the fairing. As we make our way down Electron, you can see white stripes have formed around the vehicle's black structure. This effect is created by the cold liquid oxygen in Electron's tanks, which causes moisture to condense as ice on the outside of the rocket. The first stage, the area where you see the largest white band, is essentially one large fuel tank for the 9 3D printed Rutherford engines at the bottom of the vehicle that will propel Electron through Earth's atmosphere on its way to space. Now, when it comes to launch frequency, we've implemented numerous techniques like 3D printing and automated manufacturing to help us build and launch vehicles faster and more often. But what if we could avoid the need to build a whole new stage every flight? This is exactly what our team is working on right now. We are well into our development program to make Electron a reusable launch vehicle, a process that will involve retrieving Electron from the sky with a helicopter after it has descended back through the Earth's atmosphere under a parachute. While we're not conducting any recovery testing on today's mission, you can keep an eye out for recovery developments on our 17th Electron mission coming up later this year.
okay.
In the past 3 years, Electron has become well acquainted with low Earth orbit, but in the coming months, we'll be venturing a little further, some 384,000 kilometers further. Early next year, Rocket Lab will launch a Cubesat into lunar orbit for NASA. This historic pathfinding mission supports NASA's Artemis program, which will land the first woman and next man on the moon by 2024. Using our Electron rocket and Photon lunar spacecraft, Rocket Lab will launch NASA's Capstone Cubesat into a unique lunar orbit. Capstone stands for Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment. Capstone's primary objective is to test and verify the calculated orbital stability of the near rectilinear halo orbit around the moon, which is the same orbit planned for the Lunar Gateway. The Gateway is a planned small space station that will orbit around the moon to provide astronauts access to the lunar surface. It will feature living quarters for astronauts, a lab for science and research, and ports for visiting spacecraft. Capstone will also test a navigation system that will measure its position relative to NASA's Lunar Reconnaissance Orbiter, or LRO, without relying on ground stations. Capstone is one of the first steps to learn how to operate more robust missions in this orbit, and it's laying the groundwork for future exploration of our solar system. We are incredibly excited to be part of this historic mission, and we can't wait to share it with you. So as we continue through today's count, let me hand you over to the team in Mission Control to listen in on the final minutes before liftoff.
Yep, so I think today, please, we should have a launch, because last time what happened was mm, everything was looking good. We were going and we were like, go for launch too. But I don't know what happened at T minus something, only seconds away. Not seconds away, but yeah, just once the person said go for launch, and then the seconds after, the mission was on a stand down, and I just don't want that to happen again. As he said, today it is a green window for launch, you can say. We are green to launch, and the only problem is with the
All
accumulation
stations, this is flight on mission code. From now on, there should be no red flags in your LCCs. And be advised, vehicle is currently green, ready for flight.
Oh, good.
VMS, flight on mission.
Go ahead.
please confirm flight computer as goes to green.
Confirm.
And VMS, please lock the auto sequence and confirm.
VMS is locked.
All stations flight on mission, I can confirm we're go for auto sequence start at T-minus 2 minutes.
Okay. We just if anything will hamper today's launch, that will be the accumulation of the clouds and nothing else. But accumulation of the clouds, it is not a big factor to be taken into account, but it is a factor which is to be taken, not a big but a factor. So that is on to the mission director and the launch director if they want the rocket to be launched at time.
Avionics, flight on mission code.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
All AV bats are on internal
On
power.
the auto sequence.
Confirm stage power is disabled on all 3 stages.
External power is disabled.
All stations be advised, vehicles now on internal power. PLS flight on mission.
PLS copies.
PLS, please begin lock skid reset.
Copy. Beginning recirc.
We are just now minutes from the launch to happen. Just minutes away. We are just minutes away, almost a minute away, and we are good for launch. As you can see, the liftoff bar is
PLS flight on mission.
PLS copies.
Please disable anti-geysering and confirm.
Anti-geysering disabled.
Stage 1, confirm stage 1 tanks pressed.
Stage 1 is pressed.
Stage 2, confirm stage 2 tanks pressed.
Stage 2 is pressed.
now.
Merge active.
We'll see a beautiful launch for
Galley running.
today. That's for sure. Now they just can't hold this countdown. If anything will hold, will be the engine failure or something like that. 10, 9. It's just going to start.
Ten,
9,
9, 8, 7, 6, 5, 4, 3, 2, 1.
Mission and liftoff of the Electron rocket
Vehicles get back.
to the low Earth orbit. We are done. So the next event which will come up will be the okay.
Stage 1 propulsion is nominal.
I haven't seen anything like that.
Well, after a
Hopefully
brief hiatus, Electron is back in the skies heading to orbit.
that
At T
is
plus
good.
35 seconds into flight, we're coming up to one of the first milestones of any mission to space, passing max Q. This is the point at which Electron will experience the highest
HV
amount of
battery discharge
aerodynamic
normal.
force on its way to orbit. Let's listen into the call from Mission Control.
Why do I think the propulsion is not looking good? I don't know, it is not burning fuel properly or what is happening, but I hope it does not hamper the mission and we don't have any explosions or like that.
Coming up on maximum dynamic pressure.
Max Q is coming up and it should go.
Pass through max Q.
Okay, good.
Stage 1 propulsion is holding nominal. Stand by
And there
for
you have it,
nuclear
Electron
roughly
has
30
cleared
seconds.
max Q.
Some problem with the telemetry too, and with there is some problem. There is some unburnt fuel which is being remaining. We can't even see what is happening.
Entering burnout detect mode.
AOS Chatham Station.
Coming up next is main engine cutoff, or MECO, which occurs when the 9 Rutherford engines shut down after exhausting their fuel reserves.
These
Upon
VQ3
shutdown, the
tanks
empty
which
stage
you are
is
seeing are the
jettisoned so
helium
that
tanks.
stage 2 can ignite and continue on its journey to low Earth orbit.
Now it is looking good.
30 seconds remaining.
Maybe that could be the camera problem.
Altitude is 50 kilometers. Speed is 1.6 kilometers per second.
Okay.
Seconds to staging.
Now it's time for the staging to happen.
Miko confirmed.
Stage 2 ignition confirmed.
Stage ignition successful.
That's the call we're looking for. We've had successful MECO, clean separation of Electron's first stage, and ignition of the vacuum-optimized Rutherford engine on Electron's second stage. We're approaching T plus 3 minutes into this mission with fairing separation coming up
Fairing
next.
separation complete.
And there it is on your screen. The fairing has separated, clearing the way for payload deployment, which occurs approximately 1 hour after
propulsion
liftoff.
is nominal.
We are just waiting for the kick stage to be in the particular orbit and then we'll separate it.
For the next few minutes, you'll be hearing the word nominal quite a bit. The latest call was from Kevin Garcia, our Stage 2 operator. It's one of our favorite words at Rocket Lab, and it simply means everything is going as expected throughout the flight.
Now we will also have one battery ditching, what do you say, staging, if I'm not wrong.
On your left, you'll see a view of the operators in the mission control room. These are the people you've been listening to throughout the broadcast on the mission control net, and they're monitoring all things launch related, from propulsion and telemetry data all the way through to our network traffic. We've heard plenty of updates from George Buchanan, our GNC operator today. The Rocket Lab GNC team are actively recruiting for senior roles in our Photon satellite program. So if you have a solid background in mathematics or physics, head to our careers section at rocketlabusa.com for more info.
250 seconds remaining.
2 minutes of propellant remaining to be burned.
Stage 2 propulsion remains nominal.
Up next is the battery hot swap. This step is unique to Electron and its battery-powered pumps housed within the Rutherford engines. The pair of batteries that carried us thus far are nearing depletion, so to finish the job, we swap power over to a third fully charged battery. Let's wait for confirmation from Mission Control.
We should have the battery test somewhat now only.
HVB battery discharge nominal, approaching hot swap.
Throttling down.
Hot swap successful.
And there you see, the battery was
jettison
staged
confirmed.
successfully.
As you've just heard, we've had successful battery hot swap. Electron's trajectory continues to look nominal as we hit 6 minutes and 50 seconds into this mission.
Stage 2 propulsion holding nominal.
If you're just joining us, we've had successful liftoff of Rocket Lab's Don't Stop Me Now mission aboard our Electron launch vehicle. We are nearing second engine cutoff with kick stage separation scheduled in about a minute and a half. While on this mission, the kick stage is being used in its most basic form to deploy our customer payloads to orbit. However, the kick stage can be adapted to become a satellite in its own right. With the addition of elements like higher performance propulsion, radiation-tolerant components, and solar panels, the kick stage becomes Photon, Rocket Lab's in-house designed, built, and operated satellite. Keep an eye out for our first Photon mission coming soon. The next major milestone you'll hear is CECO, or second engine cutoff. This marks the end of the second stage burn, after which the kick stage will separate in preparation for payload deployment.
40 seconds remaining.
Entered burnout detect mode.
Guidance is in terminal. Seconds remaining.
Now you will be able to see the separation, the second engine cutoff and this kick stage deployment.
CECO confirmed.
Stage separation confirmed.
And we're going to get transfer.
And there you have it. The kick stage is on its way to deliver the payloads to their individual orbits. For those of you who might be wondering what the kick stage is, here's a quick explanation of how this ingenious machine works to deploy payloads to orbit. Once the second stage takes us to an elliptical parking orbit, the kick stage separates and ignites its 3D printed Curie engine, circularizing the orbit. Using a cold gas reaction control system, the kick stage accurately orients itself to deploy each satellite to a specific orbit. Using this system, the kick stage is able to insert its payloads with precise orbits, even on rideshare missions with multiple satellites like this one. After deployment, the Curie engine reignites, propelling the kick stage to a lower orbit where it will be dragged into the Earth's atmosphere at a much faster rate, leaving behind nothing in orbit but our customers' satellites. Payload deployment is expected in the next hour or so, and we'll share confirmation on our Rocket Lab Twitter and Facebook accounts when we can. A final thank you to all of the small satellite operators on board this 12th Electron mission for choosing Rocket Lab as your mission partner. Thanks for watching, stay safe, and we'll see you again here soon. I'm Max Muncy, and until next time, this is Rocket Lab Mission Control signing off.
So guys, that was a beautiful mission which you just saw right now, and if in conclusion I have to say, we had a beautiful stream today of the Rocket Lab. First of all, where it we just saw the Electron rocket on the launch pad getting fueled up, and then finally we had a good window to launch today. We didn't have the weather violation, and finally at T-0 second we launched. Then then few minutes into the flight, I thought that that there is some problems with the engines, and the fuel is not burning properly, but no, that was not the case. Everything was good as it should be, because I think so that was because of the camera which was being shadowed by the icy frost. You you can say that. And then finally the first it passed to the max q. Then the first stage separate, then the second staging engine ignited. Then during the flight of the second stage, the battery were dished, and then finally second engine was cut off and kick stage was deployed. Now the kick stage will raise the orbit from the elliptical to circular, and it will put the payloads into the required orbit as required by the customers. So that's the case. So thank you so much for joining in, guys. Stay safe, stay healthy, and I'll meet you again today from in 4 hours from now with the SpaceX Starlink mission. So